The quotient rule in many ways is quite similar to the product rule. We already learnt the product rule, which said that if y equals u times v, where u and v are just two different parts of the function that both have x's in them, so they're both functions of x in their own right, then we learnt that y dash equals v u dash plus u v dash, or it can be expressed as v du dx plus u dv dx. This is just the simpler notation. Now I'm writing this product rule up here to remind you what it is, and so you can see the similarities with the quotient rule. When we learnt this one, we said, let's always write it this way around, with the v first, v times u dash first, and then the u times v dash. Now, it wouldn't technically make any difference if we swapped those terms around because we're just adding them. But the reason we like to write the product rule this way is because when we look at the quotient rule, you'll see that we start with v u dash, or v du dx, and then we have to subtract u v dash, or u dv dx, whichever notation you're using, same thing, just written differently. So it makes sense in both cases if we're starting with a term that has the v in it, and that reminds us which one comes first when we're using the quotient rule. So in the product rule, we've got two functions of x that are multiplied together. In the quotient rule, we have two functions of x that are divided one by the other. In the product rule, we add, and in the quotient rule, we subtract. That's one way you can remember it. Multiplying goes with adding, division goes with subtracting. The other thing that the quotient rule has that the product rule doesn't have is it has a great big fraction in it. Makes some sense when we're dealing with a function that has a fraction. And on the bottom it has v squared. Now, a way that you can remember that the v term has to come first and the v is the thing that gets squared and put on the bottom, I think v for very important. It's very important that you put the term with v in it at the front. Now, the way we apply this rule is very similar to the product rule. First, we need to define u and v, then we differentiate them, then we write out what the quotient rule is, then we sub in the parts that we have, and then we simplify it. It actually turns out to be a little bit easier than the product rule because the hardest step of the product rule is often the factorising at the end. And with the quotient rule, when we have our v squared on the bottom, really whatever is on the bottom of our fraction that we're given, our function that we're given, we can just square that, leave it in brackets squared, and a lot of the time that keeps things nice and straightforward and we don't actually need to expand. You'll see what I mean when we do our example. So if y equals 2x minus 1, say, over x squared plus 5, we can see that both of these parts have x's in them, so they're functions of x in their own right. Find dy dx. Now, if you're asked to find dy dx, write your formula out with du dx and dv dx in it. If you're asked to find y dash, you can use this version of the formula. You can be asked either way around, so it makes sense to practice it both ways. Alright, so first I need to define u and v. So I'm going to start by saying, let's start by saying let u equal all of the part on the top of the fraction. So that would be 2x minus 1, and let v equal all of the part that's on the bottom, which would be x squared plus 5. Now we need to differentiate both of those. Now we could do that underneath here. I like to do it beside. That way I've got u and its differentiation, v and its differentiation. That's just the way that I like to do it. So I know I have 4 things and I've got 4 parts of my formula as well. So if I'm writing dy dx, I'm going to want to find du dx here. That means differentiate u with respect to x. And I get 2, nice and easy. Now if I differentiate v with respect to x, I just have to differentiate this. The 2 comes down the front and gives me 2x. Now I have all of the 4 things that I'm going to need. I write out the formula. So we write dy dx equals v du dx minus u dv dx. You can put a dot between those to show that they're multiplied if you want to. Just make sure you don't write v du because then it becomes sort of confusing. I just put the v and then separately I put the du dx all over v squared. Okay, now we need to just sub in those 4 parts into our formula. So we have v times du dx, so x squared plus 5 multiplied by 2. Now we need to multiply this whole thing by 2, so it makes sense to write the 2 out the front of that part and put it in brackets. Then we need to subtract u, which is all this 2x minus 1, I might put that in brackets too, and I need to multiply that by 2x. So again, it makes sense to put the 2x outside the brackets, 2x minus 1. The whole thing has to be over v squared, which means I write out v and then square it. Now you'll find that that denominator can generally, most times, stay just like that. On the top here, if I was able to do some cancelling, if I could find that I could divide top and bottom by x squared plus 5, then perhaps I could do something. But remember, I can't cancel this x squared plus 5 with one of these ones because I don't have an x squared plus 5 over here in this term. So what I need to do is actually expand these brackets out, simplify the numerator, and then look to see if anything can be done. And most times it probably can't. So on the top I have 2x squared plus 10, and minus 2x times 2x is minus 4x squared. And here you need to be careful, don't make the sign error that we have seen so many times before. Minus 2x times minus 1, don't rush to write down this minus that's here. These two negatives will change that sign to a positive, and we have plus 2x. All over that same denominator, so just rewrite it. Now, on the top I've got 2x squared minus 4x squared, so that gives me minus 2x squared. And I have 10 and I have 2x, so I can just write all those down. Plus 2x plus 10. Now, I'm noticing that I could potentially factorise the top. I can see that I've got 2, 2 and 10 here, so potentially I could bring 2 or minus 2 out the front of some brackets and factorise the top. The only reason for doing that though really would be in case I might be able to then factorise it and get some x squared plus 5s to cancel with these ones. I can see that if I bring minus 2 out the front, I'm going to have x squared minus 5, which is not the same thing, and I'm going to have these x's as well. So you can factorise it or not. It's not going to make a huge difference because we're not going to be able to do any actual simplifying from here on. But since the bottom is factorised, it makes some sense, I guess, to factorise the top. Maybe start with a positive term like x, and then minus x squared and plus 5, and all over x squared plus 5